All right, now we're going to get into some super basic statistics things. This is just going to kind of give you some exposure to stats and some of the basic, simplest ideas, so that when you get to stats, that first couple of chapters or chapter uh, is maybe not so crazy. You've at least seen the words before. You understand what we're talking about, and then you can kind of build on that knowledge to get the rest of stats down. Okay. Now, a lot of this section is just vocabulary, specifically in this intro to stats one. It's mostly vocabulary, so I'm going to skip a few slides here and there just so that you kind of have an idea of which ones. The reason I'm skipping them is because all I would be doing is reading them to you, and that's boring for both of us. So I believe that you can read. You're in college. I trust your skills. So make sure that you read through those definitions, that you understand those definitions. On the slides that give you an opportunity to practice those definitions, give them a try. And then on the next slide after those, usually there's an answer for you to kind of check your work and see that you're understanding. Okay. All right, so stats. Stats deals largely with collecting data, giving that data some numbers, and then using those numbers to either make predictions or to infer information about what had happened. Okay, statistics is in everything. It is in every branch. It is in every field. It doesn't matter whether you're going into marketing, insurance, business, biology, medicine. Okay, statistics are everywhere. Okay, and so we really want you guys to interact with statistics and to understand where they're coming from and why these things, have a basic knowledge of where these numbers come from, so that you have a better idea of how they can be manipulated and how these numbers can be used to give false information as well as true information. Okay, so be really careful with statistics. It is one of the branches that is a little bit tricky. Okay, so this is just terminology. I'll let you read that on your own. More terminology, but these are examples of those things. Again, read that on. Stop when you get here and try it. See if you can match these, make a good educated guess, match each one to its correct terminology, and then the answers are on the next. Again, different kinds of data. Now, I need to be a little specific or want to clarify a couple of these things. The type of data that we have, whether our data is qualitative or quantitative, and if it's quantitative, whether it's discrete or continuous, all of that is going to really play a role in how we attend to the next few problems. Okay, we occasionally treat discrete data differently than we treat continuous data. We treat qualitative data way differently than quantitative. If it's qualitative, I can't put numbers on it. I don't have a mean, I don't have a median, I don't have a mode because there's no numbers. Okay. If it is continuous data, I can have decimals. Decimals are allowed, and we can round, and we can kind of have mean, median, and mode that are not part of our data set. But if it's a continuous, if it's a discrete set of data, 2.5 means nothing. Okay, so I can't use those types of things to describe my data. Okay, so the kind of data that we are working with is going to be really important in the foundation of statistics. You have to know what you're looking at before you can know how to use it. Okay. All right, so the data are the number of machines in a gym. You sample 5 gyms. One has 12, one has 15, one has 10, one has 22, the other has 20. What kind of data is this? Okay. When you're trying to decide which one, your kind of background question that you want to ask yourself is, do decimals make sense in context? If I go into a gym, does it make sense to have 3.5 machines? Well, not really, right? You either have a machine or you don't. And so we would consider this type of data to be discrete. Okay, decimals don't make sense. So if decimals don't make sense, then discrete data. Okay. The data in the next set are areas of lawns in square feet. So I'm looking at areas. It doesn't really matter what I'm taking the area of, but I'm taking an area. Okay. You sample 5 houses. I have 144 square feet, 160, 190, 180, 210. So background question, do decimals make sense? And this one's a little bit tricky. They're trying to trick you just a little bit. All of the numbers that they gave you are whole numbers. Okay, that does not mean it's discrete data. If it is something like area, where absolutely I can have like 2.5 square feet and it makes sense, then yeah, this would be continuous data. Okay, so that little background question of does a decimal make sense in this context is important. Okay. All right. So this just adds more to it. These are both quantitative pieces of data because I'm assigning numbers to them. Okay. If I was describing the color of the gym equipment instead, that would be qualitative data. Okay. All right. So try these. Go through this list, look through them, decide, is it quantitative? Is it qualitative? If it's quantitative, tell me if it's continuous or discrete. Okay. As you do that, hopefully you come to the same conclusion that we have. There are a few that can be debated one way or the other. It just depends on some context and how you're going to be able to use that information. What part of that description are you going to use? All of those kinds of things. Okay. So again, vocabulary, being able to use vocabulary, having vocabulary. Okay. Then we get into this idea of sampling. Sampling is important because if I say I want to get some data, well, the next step is how do I do that? Okay. And getting into this idea of sampling and being able to pick a sample, and not only pick a sample, but find a sample with not a lot of error and not a lot of bias is going to be your best sample, right? If I'm going to go out and I'm going to do all of the work to collect data, I better collect data that's good. Make it fair, make it unbiased, make it useful. Okay. I can go out, this is an example, okay, simple random stratified systematic cluster convenience sampling. Go get your sample. Now let's talk about what kind of sample we're getting. Okay. Again, pause here, read through it, see if you can assign your data. Once you've got it, go to the next slide. Let's see if you're right. Okay, so we've got each has been classified kind of whittled down to the basic type of sampling. Now, are there other methods of collecting data? Sure, but most of them, if you find a different method, it's typically just a combination of these. Okay, these are, like I said, the simple, most basic ideas. Once you master the basics, when you get to your stats class, we'll build on that and we'll go a little further. Okay, but for now, this is what we've got. Okay, all right, so let's apply something. A local radio station, it's a fan base of 20,000 listeners. They want to know something. Okay, they have a question. If they would prefer more music or more talk shows, asking all 20,000 listeners is impossible, right? It would literally be impossible. All it takes is one person to not answer the phone or not have a phone, and now they're not all talking to all 20,000. Okay, so we're going to use convenience sampling. I'm going to take the first 200 people that they meet at one of the concerts, and they're going to ask them. Okay, 24 people say they prefer more talk shows, 176 prefer music. Is this representative of the entire population? Okay, first of all, a convenience sample is almost never representative. Okay, there are times, there are small times and places where it could be, but it is almost never representative. Okay, why would it not be representative here? Well, my first indication of bias would be you're at a concert, and people who prefer talk shows over music are not generally the people that are going to attend a concert. So you have to be a little bit careful. Okay, so that's just one example. There are other examples of bias. After a certain age, people stop going to as many concerts. I'm not saying they stop going to concerts, but they stop going to as many. If it is a music event in the week, well, no one with a job is there because they're at work. If it is, right, so there's all of these other types of bias that you can find in a convenience sample. So we want to be a little bit careful about that. We want to make sure that we are picking samples that are fair, that are representative, that actually will give us good information and not just the information we want, right? All right, some more key terms. Variation. Variation in statistics is important. We are talking, when we talk variation, we're talking about how spread out is our data, okay? If I'm making a 16-ounce can of vegetables to put on the shelf, is every single can going to have exactly 16 ounces? Probably not, but if I can keep all my cans within 15.8 to 16.2, that's a variance that I'm okay with. Okay, so when we measure variance, this is where we start measuring things like mean, median, mode, range, tolerance. All of those kinds of words get tied into this in a similar manner. So we just want to make sure that we understand what variance is. Okay, measurement. Now, if we start measuring things, when do we measure? When do we round? When do we use the whole decimal? Why should I do that? Okay, just like college algebra, when you're in statistics, you do not round unless you absolutely have to. Okay, we want exact answers for as long as we possibly can. The sooner that you round, the more error you introduce. Okay, say you're doing a big financial calculation and the very first step asks you to divide something and you get a decimal. And say you round that decimal to 3 decimal places. Okay, after you get to the end of, say, a 5 or 6 step calculation, and maybe you're doing this for 1,000,000 accounts, that one rounding decision at the very beginning could mean a difference of thousands of dollars in your final answer, right? And that makes a difference if you're the bank. So this is good practice in that type of scenario where I'm working with statistics. I don't want to mess up. I don't want to make an error at the very first step and then just kind of carry that error along for the rest of whatever we are looking at. Okay, so as you are doing this, exact until we absolutely have to. Okay, all right, frequency. Frequency is the amount of times that something happens. So in the example of the radio station, they had 2 questions. So you had 2 options on the survey. Option 1, TV show. Option 2, or sorry, talk shows. Option 2, more music. Okay, so if I'm looking at option 1 and it happened 24 times, the frequency of that option is 24. So we're actually just counting. Okay, frequency is a fancy mathematic word for it happened this often. Okay, so then we have a couple different types of frequency that we can nail down, that we can thin out. Okay, one of those is relative frequency. This is where you are basically turning it into a probability. Okay, 5 out of the 100 people we asked were between 59.95 and 61.95 inches, and so that's our relative probability. Relative to the rest of the heights, it happened 0.05%. Okay, and then we have a cumulative relative frequency, and this one's a little bit confusing because we're just going to start adding all of our relative frequencies together and keeping a running total. Okay, so this one is a running total. So as I go, the second row here was 0.03 as its relative frequency. So we're going to take the row above it, this 0.05, add the 0.03, and we get 0.08. The third row happened 15 times, so it happened 15 out of 100, so that's our relative frequency. And then for our cumulative relative frequency, we're going to take this 0.08 from the previous row, add it to the 0.15 from the current row, and we end up with 0.23. So by the third line of our data table, the third line of our frequency table, we have covered 23% of the responses. Okay, and that's kind of what we're saying. So we're just making sure that by as we go, we've got a certain amount of data. Okay, now there's one other thing on this slide that's important. It is class size. Now remember, I said a minute or two ago, the type of data is going to change some of our calculations. This is one of those calculations. If I have continuous data, all I have to do is subtract. Okay, if I know my data is continuous, subtract, like this one, we would take 61.95, we would subtract 59.95, and we would end up with a class width of 2. Okay, if it is discrete data, okay, subtract the ends and then add one more. Okay, so we are saying, for the example, 12 and 7. So I have a class that goes from 7 to 12, and that means that that class includes the numbers 7, 8, 9, 10, 11, and 12. And if I saw any of those numbers, they would go into that class. And that means it has 1, 2, 3, 4, 5, 6 different data points in there. Okay, so when we're talking about class width, we're talking about how many different points are in that spot. If it's continuous, we can describe it with a distance, and so we can subtract. If it is discrete, we're actually saying there's this many different numbers in there, and that's why we have to add the 1 back on. Right? 12 minus 7 would be 5, and if I don't add the 1 on, right, we just counted over here that there are 6 data points. So you have to know and you have to pay attention. Is this continuous? Is this discrete? And if so, how do I calculate that width? Okay. All right, so given the frequency table below, what is the class width? And then a cumulative frequency table and a relative frequency table. Those should actually be in reverse order, but we'll make it work, okay? And then relative frequency for a class with a certain bound. Okay, so ask yourself, if I go out on the street and I ask somebody how old they are they going to say, I'm 3.5? Well, yeah, if they're actually 3, they're going to say, I'm 3.5. Okay, but ask people your own age. How old are you? No one, well, most of us don't say, oh, well, I'm 22 and 3/8, right? You say, oh, I'm 22. Oh, I'm 34. Oh, I'm whatever, right? So age, we are going to treat as a discrete data set. So our class width, pick any of the classes, they should all be the same. We're going to take 18 minus 15, and I get 3. Add that 1 back in, so our class width is 4. Okay, now I'm going to do relative and cumulative together because it actually makes more sense to do relative first. So I'm going to put relative frequency, and it's going to fit in this little column. because I did not plan this out very well, so I apologize. So first thing I need to know, how many people did we talk to? So 2 plus 2 is 4, plus 4 is 8, plus 4 is 12, plus 5 is 17, plus 9 is going to be 26. Right? Now, relative frequency, I'm just going to take the number in this column, so 2 in 26, and then simplify. So 2 in 26, which is 1 in 13, 4 out of 26, which is 2 out of 13, 4, which is going to be another 2 out of 13, 5 out of 26, which doesn't simplify, and 9 out of 26. Okay, so relative frequency is just a straight probability. How many did you talk to? Great, add them up, put them all the frequencies over that number. Okay, for our cumulative relative, now I need to add those rows together. So I have 1 in 13. Okay, the next row is going to be that 1 in 13 plus this 1 in 13. So I'm going to have 2 in 13. I'm going to take that 2 and add it to the next row. So now I've got 4 out of 13. I'm going to add that to the next row. So 4 and 2 more is going to be 6 out of 13. Then you got to use your common denominators, all of your good information. Okay, take 6 out of 13, add it to the 5 and 26. 5 out of 26. It's going to be 17 out of 26. And then take that 17 out of 26, add it to the 9 and 26, and you should get a 26 out of 26 or a 1. Okay, the very last row in every cumulative relative frequency table, that very last row should always be a 1. If it does not add up to 1, you did it wrong. Go back, recheck your work, re-add your numbers, make sure that everything is added up appropriately and correctly. It should be 1 every single time. Okay, without fail, always. It should always be 1. Now, if you change them to decimals instead of leaving them as fractions in this exercise, you probably aren't going to get 1. And that's a really good short example of like what I mean when I say you're introducing error. By simply changing it to a decimal instead of leaving it as a fraction, you've made error. You're going to get really close to 1, but you're not going to have 1. Okay? All right, find the relative frequency for the class with the lower bound of 27. So lower bound means it's the bottom of the class. So we're talking about this class right here, the fourth one down. Our relative frequency means that we are in this first column. So our relative frequency is going to be 2 out of 13. Or if you left them without reducing, 4 out of 26. Okay, reducing does not introduce error. Changing it to a decimal does. All right, given this frequency table, same frequency table we just looked at, these are all the things worked out. I changed them to decimal, and then I made it equal 1. Okay, I was a little bit creative. I used some practice being a mathematician forever and ever, and made it equal 1. Okay, it may or may not. Just be careful with that. Okay, so here's all the answers from the previous page spread out in a way that you can see them better, and so you can see them a little differently. Okay, so these ones are calculator numbers, no big deal. All right, some psych students took a standardized test. Their scores are summarized to the right in a GFDT and a CFT. Okay, this is a general frequency distribution table and a cumulative frequency distribution table, I believe is those. I don't know why the words escaped my brain. So what is the class width in the GFDT? Well, we're going to, again, we are going to discretely analyze this. We're going to treat it like discrete data, okay, assuming that you cannot get half points. So class width in the top is going to be 184 minus 180, which is going to be 4 plus the 1, which gives us a 5. Okay. Class midpoint for the fourth class. So we're going to go 1, 2, 3, fourth class. So 195 to 199. Now midpoint is just an average. So you can do this one of two ways. If it's a skinny class, right, 195, 196, 197, 198, 199, well, I can write them out, and the middle is 197. If it's a wider class, if there's like 40 or 50, you don't really want to do that, it's an average. So we can take the endpoints, 195 plus 199, and divide it by 2. And that will come out to the same 197. So if you're looking for the midpoint, just take the two ends, add them together, divide by 2, and you're going to land right in the middle. Okay. Now, what is the missing value? All right, so think here. This is cumulative at the bottom. So 12 plus 14 gives me this 26. If I take that 26 and add this 20, then I've got 46. To get from 46 to 56 takes us 10 data points, 10 values. And so those 10 values had to be in that fourth class because I'm adding as I go. Okay? So most of this stuff, if you can get the terminology down, becomes really just kind of addition, subtraction, and a little bit of division. Okay? But the terminology makes it hard. So make sure that you take the time and learn the terms, learn what the definitions are, learn how to use them. All right, so again, these are the answers. They're just worked out so that you can see calculations, so that you have things that are going on. All right, so that's it for Intro to Stats. Again, terminology, 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 terminology.